This section is going to look at network layer, which is layer 3 from our OSI layer. This section is going to look at IP addressing, routing, address resolution protocol, internet control messaging protocol, icmp. These are the topics. They're mostly related with layer 3. So we're going to discuss these topics. So IP addressing. So IP address we write down in a particular format. This is called dotted decimal notations. Let's say if we write down IP address, let's say 192, then after that 168, and then after that, let's say 10.1, like that. If you write down IP address like that, so that means this is called dotted decimal notations, DDN. So this is a decimal number. Decimal number means anything 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10, all this decimal number. So 192.168.10.1, that's how we write down. Now, any IP address we write down, we have two portions from that IP address. One is network portions, one is host portions. Network portions, usually they will be the common, and host portions, they will be the different. For example, if I write down another network address, maybe I'll write down 192, then 168, then we write down 10.2. So in this case, 10.2 is the new IP address. So we have a network portions, and then you have a host portions. So network portions, you can see they are same, but host portions, this is network portions, this is host portions, they are different. So any IP address that will have network portions and host portions. Network portions indicating which network it belongs to, and host portions is saying individual IP address for the host. And then for IP addresses, we have many different classes. Usually when you do subnetting during that time, you need to look at the class. And this is, we have class A, class B, class C, class D, class E, like different sort of classifications we have, IP address classifications. And those classifications also we need to understand. We're going to discuss later on in subnetting topics in details, but at a minimum, IP address will have some classes. Let's say currently we write down one address, this is belongs to class C. And in class C, certain number of IP address will be able to create part of that class C network. And grouping rules by network ID. So let's say network ID will be, in this scenario, 192.168.10.0. 0 is indicating network. So we use the network informations as with the configuring like 0. Under the 0, we have many other IP address, let's say 10.1, 10.2, 10.3, and so on. And subnetting why we need, let's say one big network, we break down that big network and create a lot of small network from that. That is called subnetwork or subnetting. So subnetting is required in order to have a better IP address utilizations, or if we need like more network, and to have a proper utilizations of IP addressing, basically we do subnetting. And subnetting is one of the important part in our IP configurations. So any security configurations we do, any IP address we do, we need to have a proper subnetting. Now routing means a router can deliver the packets from one network to another network. Let's say we have a router. Router do the routing. Router will send the packets from one network and can send the packet from one network to another network. It works like a post office. Let's say if I want to send some traffic from this router to the other router, so router can help us to send those traffic. So this is, we call it routing. So router can do all kind of routing. Router maintain the routing table, and routing table will have information about routing path. Like which way our traffic will go, which way traffic will be back. So there will be some informations around that. And we have few different kind of routing types. We have connected routes, static routes, default routes, and dynamic routes. Connected route means some particular interface and some subnet, they will be directly connected with the router. That is called connected route. Connected route means connected subnet will be with the connected route. Static route means from one network, we can send the traffic to another network by configuring static route. Static route kind of like a manual routing. You can configure and specify which area we would like to send the traffic. And default route, if we do not know the destinations network, and if you'd like to send out traffic from our router, during that time we are using default routes. Default route means kind of like we enable the routing and then router will send out the packets to whatever connected router, it will always send there. That's called default route. And dynamic routing, we can configure dynamic routing. Dynamic routing easily required when you have many routers. And when you have many routers and many connectivity, then dynamic router or dynamic routing can find out the best path, and after that it can send the traffic via best path. And dynamic routing, we have, let's say, OSPF, EIGRP, BGP, right, REAP, ISIS. So they are all dynamic routing protocol we have. So throughout the entire course, we're going to discuss, configure, troubleshoot the routing, dynamic routing protocol. In fact, all of the routing types you need to configure as well. Now, routing logic, router actually works hop by hop. Router will send the traffic to another router based on the configurations, and another router will send the traffic to whatever connected another router. So it always works hop by hop. So when this PC send traffic, and let's say this PC want to send traffic to this destinations device, it will send to this router. This router 1 will send to router 2. Router will send the traffic to router 3. In this way, our packet will go through the link. Yeah, router main job is to send the traffic. The process of routing forwards layer 3 packets, also called layer 3 protocol data units, L3 PDU, based on the destination's layer 3 address in the packet. The router 3 process uses the data link layer to encapsulate the layer 3 packets into layer 2 frames for transmission across each successive data link. Another thing we have in routing, this is address resolution protocol or ARP. Address resolution protocol, its main job is to dynamically identify the MAC address of an IP host connected to a LAN. So which IP address connected with which MAC address, ARP, it can find out that information. And ARP, address resolution protocol, by default, it will be enabled in our IP network. And its main job, it will find out the MAC address. Let's say a router need to know the MAC address of a PC, or PC need to know the MAC address of a router. During that time, ARP can find out that information. And ping stands for packet internet grouper. We always use the ping activity in order to test the network connectivity. So sending message is called icmp echo request. Reply message is called icmp echo reply, used for testing connectivity. So we ping and we receive that. So that's activity packet internet grouper, yeah, ping. So let's say if I do IP config, if you'd like to see the MAC address information, so you do IP config /all. That will pretty much provide us all the necessary informations for our device. Let's say if you do IP config /all, we can see from the beginning here. Yeah. So in here, I have many different stuffs. We have name of the computer, host name. Then we have many NIC card, virtual NIC card. I have some other virtualizations stuff that's why showing all these things. But let's say if we go down all the way, we can see one of the interface currently we have like this one, Ethernet NIC card. It's connected. This is localhost, Lenovo, and this is the MAC address for this device. And after that, we can see this is the IP address for this device. IP address, mask, default gateway. Default gateway is the router informations. And DHCP servers informations, right? DNS servers information. So all the important informations you can get from this IP config /all. You can check how many Ethernet connectivity you have, what is your IP address, MAC address, DNS, DHCP, pretty much. You can see all these steps. Then, if you'd like to test the device connectivity with internet, we can ping, let's say we can ping google.com.au, and then we can check like whether it's communicating or not. Google has some other IP address, 8.8.8.8. You can ping that one and see it's working or not. You can see that we sent 4 packets, we received 4 packets. That means communications is happening in a proper way, send and receive is happening. And the backend, icmp is actually helping us to do this ping activity. Also, hop by hop, we can check with Tricert, right? Tricert 8.8.8.8 like that, and hit enter. In this way, we can check how from our PC traffic goes to that destination's IP, which is the Google DNS servers. So at first, it goes from my PC to another router. From that, it goes to another router. Then ISP, and ISP finding all the routing path. Each of the hop means their individual routing path, and they are kind of individual routers. So you can see that traffic goes to here at first, from that this one, then number 3, number 4, number 5, number 6, 7, 8. So in between all of the number, they're actually indicating hops, individual hops. So Tricert, with that, we can find out all the hops. So router work hops by hop by hop. So that means we send the traffic to this router will send the traffic to this router will send the traffic to other one. In this way, it will go to destinations. And the tools we are using, this is called ARP, Address Resolution Protocol, ARP-A. ARP. address resolution protocol command, it can find out the address resolution protocol command, it can find out the IP address and MAC address informations. IP address and MAC address informations. Like that. So the IP and MAC address. So that's actually based on the local area network. Let's say this is 3.101. This is another IP address somewhere in our local area network. It can find out that some of the info and some of the MAC address connected with those IP address. So address resolution protocol can find out the local area network informations.